All right, guys, I'm back for the second part of section 8.1. And so in this part, we are converting not points, but equations to back and forth between rectangular and polar. So first of all, let me just tell you, so Desmos does not support polar graphing, but you can do it on your calculator. So if you go to mode and you go down here to where it says function is like rectangular. Parametric we don't use, but polar we do use. So if we click polar, and then if you go to your y equals, you're going to see that they all start with r instead of x or y. And r meaning the radius of the circle. So your r is kind of like your x, and your theta or your angle is like your y. And so if I would graph, let's say r equals 2. Now let's just think about that a minute. That's saying all the points on the polar graph that have a radius of 2. So that's the exact definition of a circle. Now I will say when you do pick up your calculator for the first time especially, click zoom, and we are going to zoom 7 for trig to make our graph look right. And ding-a-ling, make sure you're in radians. Okay, so here you see the polar equation r equals 2. Now if you remember right, for rectangular equations that graph to a circle, it's x squared plus y squared equals r squared. So the equation that would replace this would be x squared plus y squared equals 4. Phew, I had to think a minute. Would equal 4. That would be the polar form, or the rectangular form of r equals 2. So if you would change this and you would just graph an equation that was theta equals something. Now let's think about what theta can be. I can't graph theta equals anything on here because just like with rectangular equations, I can't graph x equals 4. So because it wouldn't be a function. So it works the same here. I'm not going to be able to change. I can't change that r to my theta. But if we think about it, what that would be saying is if I wanted to graph theta equals, say, pi over 2 or 90 degrees, that would be a straight line through the y-axis straight up and down through 0 because the radius is nothing, but it would want to have all points that you could have, all radiuses, I guess, that you could have if your angle was 90. So it'd be a straight up and down line. Or if you did theta equals pi. Pi would be opening to 180. That would be a straight horizontal line through 0 because your radius is 0, etc., etc. And so just visualize, there's lots of different graphs. Polar graphs can actually be very pretty. Let me get a few polar graphs up here just to show you what some of them can look like. So let's graph 5 sine of 4 theta. Whoops. 5 sine of 4 theta. That's the polar graph. If I would graph 2 minus 3 cosine theta. That's the polar graph. So the graphs can actually be very, very pretty for polar equations. And I just kind of wanted to show you some of them because it really helps to visualize what is happening when you're converting these back and forth. Okay, so let's go. Now let's just start with question number 1. Now, just as a reminder, the things that we use to convert back and forth would be x squared plus y squared equals r squared. We could potentially need to use tangent of theta equals y over x. We could potentially need to use x equals r cosine theta and y equals r sine theta. And I think that's pretty much, I think that's pretty much all of the ones that we could use. So let's start with the first one. Write the equivalent equation in using polar coordinates. So we have an x. So we know that x equals r cosine theta. So we'll replace that. R cosine theta plus 2 times y, and y is r sine of theta equals 6. Now, in order for it to be a polar equation, it has to be solved for r. So once we do our substitution, we literally just solve this for r. So I have 2 terms with r in them, which means I'm going to need to factor out the r. That would leave cosine of theta plus 2 sine of theta equals 6. So then to solve for r, you just divide both sides by that big mess. So you get r equals 6 over cosine theta plus 2 sine theta. And that is the answer. Okay, let's go to number 2. We have x equals -3. Remember, x is r cosine theta. So to solve that for r, all we do is divide by cosine theta, and we'd have r equals -3 over cosine theta. However, 1 over cosine theta is equal to secant of theta, so technically we should switch those out. I do not know if Alex would accept -3 over cosine theta. I'm not sure. All right, 3. We have x squared plus y squared. Anytime you see x squared plus y squared together, that's equal to r squared. So r would be 4. Okay, 4 x squared equals 5y. So since both x and y are not squared and it's not in the form x squared plus y squared, we have to go back to our r cosine theta is x, but that's a squared, and r sine theta is y. So that's going to be r squared cosine squared equals 5r sine theta. Now the thing that's going to feel weird to you here is we're not used to dividing by variables, but in this case we're allowed. So the first thing we're going to do, since one of our equations has a square and one of them does not, just divide everything by r, and that'll leave us with r cosine squared theta equals 5 sine theta. And so now divide both sides by cosine squared, and we have r equals 5 sine over cosine squared. But we should write that as sine theta over cosine theta times 1 over cosine theta. Because I think the goal is to generally not have any trig functions in the denominator. So if we can avoid that, we should. And then we also need to write it in trig functions in the smallest powers that we can. So sine over cosine is tangent, and 1 over cosine is secant. So this would be 5 tangent secant. All right, so now getting down to number 5, it starts to get more, the algebra part of it starts to get just a little bit annoying, to be honest. Because let me think about this. Let me try something here. So if I factor the y minus 1, I may have to like backtrack on this, but let me just try it. If I factor the y minus 1, that would be y, not factor, sorry, multiply it out. Y squared minus 2y plus 1 equals 0. I just FOILed. Okay, and I don't know why I said equals 0. It equals 1. Okay, well, these ones would be gone. So I'd have x squared plus y squared minus 2y equals 0. X squared plus y squared is r squared. And y is 2 sine of theta. Okay. Divide both sides by r. That's going to give us r minus 2 sine of theta equals 0. Move over the 2 sine of theta, you're done. And that's right. So, okay. So what made me think to do that was I knew I had to FOIL this, whatever it ended up being, whether we changed it to coordinate form or polar form or whether we left it rectangular, that's what was going to have to happen. And so I tried to simplify it first before substituting. Okay, I'm going to show you, I'm going to start the alternative and then show you why this was easier. So our only choice here would be to write this as r cosine theta minus 2 squared plus r sine theta minus plus 3 squared equals 13. And then we'd have to FOIL these. Okay, but what would eventually end up happening is we'd get a sine squared plus a cosine squared. I'm going to go ahead and finish it that way. Okay, so if I FOIL this, it would be r squared cosine squared minus 2r cosine minus 2r cosine. So minus 4r cosine. And then negative 2 times negative 2 would be plus 4. Do the same on the other side. So r squared sine squared plus 6r sine plus 9 equals 13. Okay, well, 4 and 9 is 13. So if I'd subtract 13 from both sides, those would be gone. And so what I have now is r squared cosine squared. I'm going to write the other squared term first, r squared sine squared minus 4r cosine plus 6r sine equals 0. So here we'd factor out an r squared. Okay, and cosine squared plus sine squared is 1 from our identities. So then we just have r squared minus 4r cosine theta plus 6r sine theta equals 0. Divide everything by r, and you would get r minus 4 cosine theta plus 6 sine theta equals 0. So r would be 4 cosine theta minus 6 sine theta. Now I'm going to try to simplify before I substitute. So I'm starting back with the same problem. I'm just curious here if this is going to be faster. So if I FOIL this, I'd get x squared minus 4x plus 4. And if I FOIL this, I'd get y squared plus 6y plus 9 equals 13. So the 4 and the 9 and the 13 are gone. X squared plus y squared is 1. Oops, sorry, is r squared. Is r squared. Let me write that out for you. So I have x squared plus y squared minus 4x plus 6y equals 0. X squared plus y squared is r squared. X is r cosine theta, and y is r sine theta. And so, divide everything through by r, you end up with r minus 4 cosine theta plus 6 sine theta equals 0, and so you end up with the same exact answer. So I don't know if it's necessarily easier, but it is a little bit shorter just because I don't have to write cosine squared, cosine, sine squared so many times. But either way will work. Okay, 7 you do the same way. So I don't really feel like I need to write that out. That would be 8 sine of theta minus 6 cosine theta. All right, it kind of switches gears here in number 8, and it talks about what kind of line. And that's kind of why I was talking to you about like what the equations should look like. Now, sometimes if you're really good at visualizing, you can kind of just like figure it out. Like you can kind of just visualize and be like, oh, it's going to be this. Sometimes you may, if you're not super good at that, you may need to graph it and see if you can figure it out from there. But just be careful. If there's not an r in the equation, if it's not solved for r, then it's not going to graph. But I did go through them, and I was like, because at first I was like, holy crap, there's no like list anywhere. There's nowhere that says if the equation looks like this, then this is the type of function you're going to have, at least not for these kind. And I feel like I remember that being in my old pre-calc book, but I couldn't put my fingers on it. But then when I looked at the questions, I was like, oh, it doesn't matter anyway, they're easy. So anything that starts with an R is going to be a circle. And then the next step says, well, write that in rectangular form. And so if we have R equals 8, I don't really have a substitution for just plain old R, but I do have a substitution for R squared. So if I square both sides, then I can substitute R squared for X squared plus Y squared. And so X squared plus Y squared equals 64 is your equation there. And that might be easier for you to identify what type of curve is going to be represented. All right, so here we have R equals negative 6 secant theta. Now that would be one that if you wanted to, you could graph and see what it's going to look like. So let me do that with you. That would be negative 6 divided by cosine of theta. So why did I do that? Well, there isn't a secant button on the graphing calculator. So anything that is in any of the reciprocal functions, you have to change them to their one of the three, sine, cosine, or tangent. So secant's 1 over cosine, which means this would be negative 6 over cosine. So now if I graph, I see that I'm just getting a straight line at negative 6. So when I'm asked what kind of equation, it would be a vertical line. And so then when it's wanting you to figure out what that is, to switch that into the other form, R squared equals negative 6 secant theta. So this would be, oh, it's not R squared. It's R. So I would need to square both sides and get x squared plus y squared equals 36 secant squared theta. And secant squared is 1 over cosine squared theta. So So we have x squared plus y squared equals 36 over, and cosine is r, ooh, okay, so now I'm having a little bit of a mental block here. R equals negative 6 secant theta, but we're going the other way. So when you're going the other way, negative 6, 8. What is the answer? Well, it should be x equals negative 6. That's what it should be. Let me try something else here. Okay, so if I would write this as r equals negative 6 over cosine theta, aha, multiply both sides by cosine. R cosine theta equals negative 6. R cosine theta is x. So the equation is x is negative 6. Whew. I was having a brain fart there. Okay, number 10. So number 10, notice, does not give us a number. It just says A. So if there's any number here, how would this equation look? If we put any old number there, well, we already know. Well, okay, let's just do it. Let's put a number there. Let's go to our equations, and let's just put a number there. 6, what was the function? Sine theta. And I need to change my window so we can see it. Where's my y? Y max. Okay, well, that didn't work. Why is that not working? Oh. There we go. So we can see that that's going to be a circle, but the difference here is the center is not at 0, 0. But we can see that at least it's a circle. So the answer is circle. And so now we have to take this and figure out how to write that as a rectangular coordinate. And I feel like I should take a second. I should have looked at this lesson ahead of time, right? Let me just think about this a minute, because we're not going to have a number, but we also don't have a value, like a number to put in there. So what would happen if I would square both sides? And that would give me r squared equals, oh, no, no, no. How about this? How about we multiply both sides by r? So that gives me r squared. The same as squaring both sides on the left side, but on the right side, then I would have a r sine theta. And what is r sine of theta? Well, that would be y. So now I end up with r squared equals ay. And r squared is x squared plus y squared. Okay, so I got that far. Now, I don't know what form. So I can't have, I can't have y's on both sides. Oh, okay. And if it's a circle, it would need to be written in circle form. And if you remember to do that, we need to complete the square. So to complete the square, you find the magic number, which is this number, divided by 2. Oops. So it would be a divided by 2 squared that gets added to both sides. And so then this would become x squared plus y minus a over 2 squared equals a squared over 4. So again, I'll just say this again. I've never done anything like this with polar in the polar section before. That's just, yeah, never done it. Okay, so moving right along, 11 is going to be a line through 45 degrees, which would mean it's not horizontal and it's not vertical. And if it's at 45 degrees, I don't even need to do any of the math. I know the equation is going to be y equals x. Okay, so this one is just like the cosine one we just did. It's going to be circle, and instead of the a over 2 being on the y, it's now going to be on the x. Okay, so let's see. I'm not really sure which of these it's going to be. Let's put a number. I mean, the number could be 1, which would make it just 2 over cosine. So I think it's going to be a circle. No. Vertical line. 2 divided by cosine theta. Vertical line. Oops. And what would be, let's go back here. Our vertical line was through the point 2. Our x is 2 there. And so our x would be 2. Our equation would be y equals 2a. Or shoot, x equals 2a. Okay, 14. So pretty much the same thing. So this is going to be the line y equals x. This is going to be angle of 0. So the horizontal axis, which is the x-axis, and then this would be the y-axis. Okay, so these are kind of like the ones we were doing before where we had to like add a rotation and subtract a rotation. And so what it's asking is, will this and this end up being the same point? And it will not. If they switched this and did theta minus pi, it would be, but not the way it's written. So do not. But should that matter? Yeah, it should matter. Okay, so let's look at it's got to be the one with pi. So whether I do theta minus or theta plus pi or minus, theta plus pi or pi plus theta, still the same thing. 16, are these going to be the same? Okay, so if the r's are both the same, both positive or both negative, then the only way to make them the only way to make them the same point would be if this is a plus. Your n could be positive and negative. So this would be a do not. These are dumb. Okay, so these are, they do not, and it should be theta plus or minus n pi. 18 would be, okay, so these are a little different. This is saying that you have a circle with a radius of 5, and you're shading everything outside the circle. These are inequalities. So do you shade outside the circle or inside the circle? And in this case, because it's greater than, it would be outside the circle. So here we'd have a circle with radius 1, and then a circle with radius 4, and what would be shaded would be everything in between them. Uh, 20. So these are going to be sets of points that are in the first and third quadrant because it'd be 45 degrees. This would be, because they're less thans, you would be between the circles. Okay.